Hello. My name is Edward Thomson. Real quick introduction. I'm actually the co-maintainer of an open source product called libgit2. And I mention that because the other maintainer is also here today, Carlos Martin. You heard from him earlier, talking about some of the difficulties, the top 10 worst repositories to store at GitHub. I actually want to also talk about some repositories that are difficult to store, but this time in my day job at Microsoft. I work on the Visual Studio Team Services team at Microsoft. If you don't know what Visual Studio Team Services is, it is our, version control, bug tracking, continuous integration, continuous delivery platform. And we built it for customers. We built it to sell on the market. But we also want to use it within Microsoft. And so it's become the core of what we call our one engineering system, which the goal of is to bring everybody into the same sort of engineering system. Because a year ago, 2 years ago, everybody was using different components in order to build their software. The Windows team, the Office team, they were using totally different technologies for version control, for build. And the problem with that is people move teams a lot, and so you have to relearn everything. Just looking at a version control perspective, we had a lot of different technologies. We have a lot of people using Source Depot, which is a centralized version control system. It's a checkout, edit, check-in kind of system that, frankly, you've probably never heard of. Then we also have a lot of people using Team Foundation version control, which is kind of the successor to Source Depot. And people are using those because they scale really nicely to very, very large repositories. For people in smaller repositories, we've got a lot of people using Git, but there's really no commonality, which is why we were trying to move into one engineering system. A year ago, 2 years ago, if you looked at a graph of maybe what our engineering systems looked like, sorry, wrong slide. But that does kind of convey the point. Like, you had multiple teams building multiple version control systems, and not a lot of people collaborating, maybe. So that was a little bit problematic. One engineering system is designed to fix that. The goal is to move every developer and every project into Git and into Visual Studio Team Services. And that should be fine, right? Because I read on the Git website that it was built to handle large repositories from day one, like the Linux kernel. So we thought, this would be no problem. And if you look at the Linux kernel, it is rather big. If you check it out, just the source and the tests and the documentation takes up about 640 megs. Spread out over 57,000 files. That's quite a bit bigger than, say, Roslyn, the C# compiler, which is 230 megs over 12,000 files. Right? So Linux is pretty big as far as version control, or pardon me, as far as open source projects go. But when we start looking at Linux compared to some of the repositories within Microsoft, it's not so big. The project that I work in, Visual Studio Team Services, our repo takes up 3 gigs, not like the repository and the history. I'm talking about just the source code that gets checked out. And the build tools and the docs and the tests, you can argue that maybe that's a little bit big and we're a little bit bloated, but we're not as bad as you might think. We've got 110,000 files, 3 gigabytes. We've got 300 people working in this repository every day, writing code and committing it. So that's kind of a big repository, because at Microsoft, when we talk about big repositories, we talk about one thing, and that's Windows. Windows is 270 gigs of source and tests and build tools. People have been checking into it for 15 plus years. It is gigantic. And it's in a monolithic repository, a monorepo. Everything's all in one place. The kernel source, the device drivers, Notepad, it's all right there. So that's 3.5 million files and 4,000 people working in it every day. So that's what we think of when we talk about big repositories at Microsoft. By any dimension, this is way bigger than the top 10 worst repos at GitHub. And we can't say, no thanks. We can't say, please don't. We have to say, yes, please. So really, scaling to the point at which we can support these sorts of repositories like Visual Studio Team Services and like Windows has been a real challenge for us. When we look at the ways that we need to scale Git in order to support enterprise-level Git repositories, there are a couple of places that we need to worry about scaling. First of all, for a large team, like 300 developers all the way up to 4,000 developers in the same repository, we need to look at the frequency with which people are doing pushes. Because you start hitting deadlines, people are pushing really, really fast, it turns out. And we need to be able to keep up with that. We need to worry about the number of branches that exist at any point in time in a repository. And then we just have the raw scale problems of putting that many files into a repository and having a history that's that deep. So this has been a multi-year process for us to get to the point where we could put Windows into Git. Several months ago, we announced the first pilot programs. Today, we're announcing that we now have 90% of all developers, so about a little over 3,500 developers working in a Git repository, a monorepo that contains all that Windows source. They're doing that every day, and we're very happy to say that they're actually succeeding with it. So how did we get there? First of all, if we look at the speed at which we can handle pushes in a service that's hosting Git repositories, what kind of problems do you see? It turns out, if you're familiar with Git, you've probably tried to run git push, and the server has told you that your commit is not fast forwardable, or whatever elegant language Git decides to use to tell you that that's wrong. What happens is that in order to push something up to Git, you have to make sure that you have the latest version from the server, right? So you have to fetch that. You can merge your change in with the latest version, and then you can do a push. Otherwise, you'd have to do a force push, and you'd destroy whatever was there that you didn't have. So obviously, what you want to do when collaborating is to make sure that you're integrating everybody else's changes. The problem is, in a busy repository, there's a lot of contention here. So what happens is, you'll clone down a repository, you'll make a little commit in your local repo, and when you go to push, you'll notice that somebody else has beat you to it. So you've got to fetch that, and you can either merge or rebase your commit onto that, and then you can push again. But when you're dealing with 4,000 developers, and if they have a deadline, then people are pushing all at the same time, and it's very easy to lose this race. You can get into a point, and this is not hypothetical, you can get into a place where you're just sitting there running fetch, running merge, and running push, and and you can get beat quite a bit. This was happening just with our little, comparatively, VSTS repo with about 300 developers in it. It turns out that a great solution to this problem is what you're probably already using for code review, and that's pull requests. In Visual Studio Team Services, we enforce that. We make sure that nobody can push to master. You have to go through a pull request in order to get your changes merged. And that allows some of that contention to be reduced. What it really does is reduce the cycle time. Now you don't have to fetch to your machine, you don't have to do the merge, and you don't have to push again, right? Because that kind of favors the person who's network-wise closest to the server. Instead, the server takes care of doing the merge and just integrating the changes for you. The other thing is that we had to build into Visual Studio Team Services what we call the merge queue. So for any branch, let's say master, when you're trying to complete a pull request and merge your pull request in, when you click that button, you actually go into a queue. So if 50 people click the button all at once, one at a time, people will be merged from their pull request into master. And that ensures that, when you're the 50th person in line, you'll eventually get in, getting merged behind the 49th person. And you won't get into a place where 50 people click it at once, the first person gets in, and 49 people get a little red box. That's not ideal. So this allows to remove the contention. It'll still fail if there are conflicts, of course, but otherwise, 50 people can click at once, and they'll go right through. Another problem that we saw very quickly, and Carlos alluded to this also earlier in his talk, is the number of branches can become really problematic with Git really quickly. If you have 300 people, each creating several topic branches, every time you run git fetch, you're going to get everybody's topic branch. And for Windows, that can be a little annoying. If you're working on Notepad, and all of a sudden the entire Xbox team is going crazy adding new features, when you run git fetch, you probably don't care about their topic branches. They're working on Xbox One or whatever. You're just trying to, make your little text editor work, and you don't want to download all of their changes all of the time. The other thing that's problematic is that Git, when you just run Git commands, like Carlos said, a lot of them open up and look at the entire space of the references, the branches, and the tags. And so if you have a lot of them, it slows down. And the way Git is architected, where Git invokes other Git processes, you'll see that slowdown for each of those commands that it executes. So it's slowing itself down. We found that at around 10,000 branches, Git starts to get pretty slow. At 100,000, it's basically unusable. And you can ask yourself, who on earth would have 100,000 branches? And the answer is a team with 4,000 developers. Because 4,000 developers, even if each one just has 25 topic branches, you got to 100,000 real quick. So we had to find a solution to that problem. Our sort of back-of-the-envelope calculations when we started working on this was that the Windows repo would get to 150,000 branches. I actually think that's really conservative. I think that it will be a lot more. So we put something in Visual Studio Team Services. We call it limited refs or limited branches. The idea being that if you look at the entire branch structure of your repository, you can really quickly look at things that you care about, right? I care about the master branch. I care about release branches. I care about any branch that I've created. But my coworkers, as much as I love them, I don't care about their branches. I don't want to see what Bob's done. I don't want to see what Alice has done most of the time. And so Visual Studio Team Services has the functionality. When you clone from VSTS, when you fetch from VSTS, you'll authenticate to it. And so it can show you just the branches that the server administrator has selected as everybody gets these branches. So release branches, master, that sort of thing. You'll be given any branches that you've created. You'll be given all that data. And you'll be given branches that you've favorited. So you can go on to the VSTS website, find the branch, click that little button, and now all of a sudden you'll be enlisted in that branch as well. So when you run git fetch, now I can go get my coworker Chris's change. I want that admin update because I want to code review it, or I want to build it and test it. So it's very easy to get new branches. But otherwise, I won't see that branch. And so he could check in, 100 commits, many files, maybe he had some binaries, and I won't get that unless I actually go in and list in it. So for the most part, that cuts things down to dozens of branches for the typical developer, and it's much faster. A lot of people say, why don't you use a fork for this? You could fork a repository. Everybody has a separate repository. We found that forks work really well for permissions. Like in my open source project, I don't want everybody to be able to create new branches. I want them to create a fork that is separate from mine, that doesn't pollute my space, and then they can pull requests from there. But that's not really true for a typical business workflow. I want to be able to easily get my coworkers' changes. If you're in a fork, you can go get that stuff if you open up your Git config and add a ref spec. I actually never remember what it looks like, so you have to Google what ref spec to add to get a fork into your repository. And then you can do that. It's much easier to go to a website and click a button. If you're a command line person, you can still edit the config file yourself, or you can script that. But on the whole, it's much easier to just click this button than it is to have an actual separate repository. Okay? Finally, and this is by far the biggest problem that we had to face, is the actual size of the repository. And when I say that, I mean the size of history itself, first of all, because when you clone a repository, by default, you get all of history. And with 4,000 developers, the Windows codebase moves very quickly, as you can imagine. We have, so like I said, 3-4 months ago, we started moving people into Git on the Windows team. And in those 4 months, they've added 250,000 commits. So it's punishing the size of history. Could you do a shallow clone, is the question. A shallow clone, if you're not familiar, is the Git terminology to give me just the most recent commit. And yes, you could. But then you get into a problem with the raw number of files. Again, there are 3.5 million files just in the latest version of the Windows repo. So when you do things like running git add even against a repository that large, it is punishing. Because what happens is Git will open the index file, read it into memory, figure out what path you're trying to add and where it belongs in that file, in that list of 3.5 million other paths, and then save it back out. And this is an operation that happens quite a lot, and this happens for merge, for rebase, checkout. Basically, every Git operation is slow in a file system this large. We've decided that it was basically unusable. The first thing we did was try to componentize the Windows repository. We tried to split it up into several submodules. We decided we didn't like submodules. Raise your hand if you feel the same way, right? We tried to lay them down with Android's repo tool. But fundamentally, there are just problems when you split a large code base up that is kind of intertwined, like Windows is, into multiple repositories. The biggest problem is that there's not a lot of good tooling to tie these repositories together. So if you, say, make a change that spans multiple repositories, it's hard to see an atomic change across all of them, right? There's no real good system to organize that. The other problem is you're just making a change in multiple repositories. If you're changing an API that multiple programs access, then you're making a change. We call that a cross-cutting change at Microsoft. Then you're making a change across all of those repositories. It's really punishing. So we wanted to make sure that we kept Windows in one single repository, a monorepo, for collaboration. The problem is, when we tried it, it was bad. Like, it was real bad. We tried to clone, and it took 12 hours. And it didn't finish. That was when the network flaked, and there are no restartable clones in Git. We finally got it to succeed once, and I think it took 4 days. Checkout, took 3 hours. Running status took 8 minutes. When nothing had changed. And you can point to this and say, well, NTFS is kind of a slow file system. And I'll give you that, it is, compared to ext3, even HFS+. The file system on Windows, NTFS, is not super duper fast. Granted. But there's like 30 minutes to do an add, to add one file and commit it. There's no way that is 10 times faster acceptable? No. Is 100 times? Still no. This was simply problematic. So we had to try to come up with a rather original solution And that solution is what we call the Git Virtual File System, or GVFS. The goals are that GVFS will only download what you need when you need it from the server. The idea there is that we can make Git linear, in linear time, on the number of files that you've used, that you care about, not on how many exist in the entire repository. And most people don't need that many, comparatively, of these 3.5 million files. If you're working on Notepad, you really don't care about some SCSI driver from the mid-90s, right? Which is probably still in the Windows repo, I promise you. So that's the idea behind GVFS. It was rather experimental. Again, 4 months ago, we started bringing people in, and we were really happy with the results. We got clone down from 12 hours and then failing to 90 seconds and actually succeeding. Checkout takes 30 seconds, status takes 8 seconds, down from 8 minutes, and adding a file and committing it, 10 seconds. How did we do this? Well, lots of magic. GVFS, as the name implies, does stuff with the file system. The idea is that when you do a clone, when you run git clone, when you run GVFS clone, that is the one change, significant change that we made, is the bootstrapping process. So there's a command called GVFS that does a clone. But what it does is it downloads only a limited amount of data from the repository, the most recent 2 commits, and all of the trees. If you're familiar with Git structure, this is basically enough to have information about the commit and about the files that are there, but it doesn't get the files themselves. Normally when you run git clone, you'll get all the files, all of the blobs, and then they'll be checked out. With GVFS, you only get the trees. You don't get any of the files themselves. This is just enough for us to, first of all, set up the sparse checkout file in Git. And what we're doing there is we're telling Git that we don't have any of these blobs. We don't have any of these files. And that allows Git to very efficiently skip looking for them. So that's why status is fast. Git says, you don't have any files. I'm not going to go looking. Wonderful. But what GVFS does is it adds what's called a filter driver. If you're not familiar with like the NT kernel minutia, what a filter driver is it sets a level above a file system driver. So we still use NTFS, and that's where our data goes, where the files go. But sitting on top of that is a filter driver. And it can intercept syscalls, like open. A filter driver is commonly used to support antivirus software. So they can hook into open, and they can actually go hit the disk, read the file, scan for a virus, and if it passes, can hand it back to the operating system. We're doing something a little bit different. We're intercepting open and or create file ex on Windows. And what we're doing is we're looking to see if the file actually exists on the NTFS volume. And if it doesn't, we'll just go fetch it from Visual Studio Team Services. And so we're paging these in as they're opened. So if you run dir or ls, you'll actually see all of your files. They will appear to exist. That's the filter driver's magic. When you actually open one of them for read, we'll talk to the GVFS driver, which will talk to Visual Studio Team Services, download the blob, and then actually put it on disk. So now it exists locally. And so files, as you read them, will be paged in. It turns out that this is actually, this sounds a little crazy. It sounds like it's awfully slow, but it is obviously so much faster than trying to download the entire repository. The benefits to this, to GVFS, is the only change that we've fundamentally made, except for hacking on Git itself in the open source project and contributing that back, is GVFS Git. So that means everybody can use the stock Git client. So people know how to use it. They can go to Stack Overflow and figure out what a merge is versus a rebase. They can read the Git book and get all the information. We didn't invent a new version control system. We've done enough of that at Microsoft. We're really happy with Git. We've got everybody in a single repository. We didn't split it up into multiple sub-repositories that are layered together with Android or something like that. So that allows for the collaboration that goes on when everybody works in a single repo. And you can use Git tools, right? Anything that runs the Git command line client. So, you know, Visual Studio will support GVFS. We've got source tree and tower support. They've committed to support. They're testing it with GVFS. Git Kraken is very excited to add support later. So people can use the tools that they like to use because it's just Git. Okay? There are some limitations. Obviously, since this downloads blobs from Visual Studio Team Services, you have to be online the first time you open a file so that it can go and fetch that. But actually, after that, all of the Git distributed, nature kicks in because you have the files on disk. So you can merge, you can rebase, even if you're on an airplane disconnected, as long as you're not opening any files that you don't already have. Only the Git command line client right now works with GVFS. That was where we did all our hacking to make things work. We've added some things like the ability to go to the internet and get files, which is not something that exists in Git without some patches. They're on the mailing list. We're getting them into the project. But we haven't done that for libgit 2. We haven't done that for JGit. We haven't done that for Dulwich. That means that if you're using a client that depends on that, it won't work. There are no cleaner smudge filters, so we very quickly ended the debate on how to do line endings in the Windows repository. The reason is that we need to know the size of a file before we have it and put it on disk. This clean and smudge filters can change that, right? If you monkey with line endings or something, you'll change the size of a file. We need that to be consistent from the time it's virtualized and only existing in the cloud to the time it hits the developer's machines. And finally, some commands just don't work. You can't run git grep anymore because git grep would scan the entire file system, scan the entire tree, looking at the blobs, looking for whatever you're grepping for. And that would cause it to download all of the 3.5 million files in the Windows repo. So that's out. You can also not run commands that validate the Git repository and go looking to make sure that all the objects that it says exist actually exist, because they don't. They're all in the cloud still. So we turn off a couple of commands, but for the most part, everything works. Again, merge, rebase. You can create branches locally. It's very straightforward, as long as the first time you open a file, you're connected to the network. One of the other things that we've added relatively recently is a cache server. Obviously, when you're pulling things off the network, you have to be close to them network-wise. We have about 20 of them behind a load balancer in Redmond. We've just started spinning up geographic replicas. So it turns out if you're a Windows dev in China, your access to the Windows source is faster than if you're in Redmond, because theirs is right down the hall, their cache server. The cache server for Redmond is in some data center somewhere. So coincidentally, it works out very well, but we need to beef that up a little bit. Finally, the last way we needed to scale this was teaching people how to use Git. Bringing 4,000 developers into Git all at once was a challenge. Obviously, we did it over 4 months, but at Microsoft's scale, that's kind of all at once still. So we did a lot of in-person training, but by far the most effective solution we had to this was every team got a Git champion. So instead of training everybody, all 4,000 developers, on absolutely every detail about Git, we trained just one person within the team, a champion, and they could build out that knowledge within the team themselves. So they were given the tools and the resources they needed to train just their team, hands-on, and to be available to their team when they had problems. So, Saeed, my coworker, who was actually supposed to present to you today, unfortunately fell ill. He's writing a series of articles about GVFS and how it works at a technical level, way more than I could go into in just this quick 30-minute talk. I would really encourage you to check it out, visualstudio.com/learn/git-at-scale. And the GVFS project itself is open sourced at github.com/Microsoft/GVFS. Thank you.